All right, we are continuing with our work with probability, mostly with expected value and how it applies to the concept of insurance. So the first problem that we're looking at here is a hypothetical situation about phone insurance, or whether you should buy it based on probabilities of things going wrong. So expected value tells you more about risks and costs you face. It can be helpful when we're trying to figure out what insurance to buy or if to even buy it. So here is buying a new phone for $700, wants to know whether it's worth paying for the additional insurance. She has the option to add an insurance plan that costs $180 for 1 year, covers 100% of the cost of repairs. Now you think about yourself and whether you've ever broken your phone. I personally have never broken a phone. I've never even cracked a screen, so I don't bother with phone insurance, but you can think about whether it's something that you would consider doing. But let's look at the math behind it in this situation. So Hira faces the following risks of damaging her phone. There's a 30% chance that she goes the whole year with no damage and therefore no cost. There's a 35% chance that she does damage her screen, which would cost $100 to repair. And that may or may not be realistic anymore, but that's a nice round number to work off of. There's a 30% chance that she does some minor damage to the phone beyond the screen that costs $200 to fix. And there's a 5% chance that she does major damage, which is going to cost her $500 to fix on a $700 phone. All right, so that's the premise of the problem. All of these different probabilities of these things happening. All right, so for simplicity, assume these outcomes are mutually exclusive, so only one of them will happen. So she's not going to get both minor damage and major damage, okay, just to keep the problem simple. So what's the probability that she has to pay for some kind of phone repair over the next year? So screen damage, minor damage, major damage. So the probability of some sort of damage would be the sum of those three damages, right? So 0.35 for screen damage plus 0.3 for minor damage plus 0.05 for major damage. All of that adds up to 0.70, which would be a 70% chance of doing some kind of damage to her phone. Now you can get that even faster by looking at the no damage percent, right, and just taking 100 minus 0.30. That would be doing the complement of damaging the phone, but that's just adding the three probabilities there. Okay, so calculate the expected value for the outcomes above. This tells us how much she should expect to pay in repairs over the year. All right, so we have a 30% chance of doing zero damage. We have a 35% chance of doing $100 of damage. Now, each of these multiplications, you'll recall, is probability of the event times the value when the event occurs, right? So 30% of the time, we're going to have damage, no damage, which is no dollars. 35% of the time, we're going to have screen damage, which is $100. Trying to put the dollar value on each event. So we have 30% of the time doing minor damage, and when that happens, it's a $200 bill. And we have a 0.05, so 0.05 chance of doing major damage, which is a $500 bill. Okay, so we just go straight across. You could put this entire thing into your calculator just as is. You don't have to break it down piece by piece. But the total on this comes out to $120. If you haven't already paused to figure that out, pause now, go back and do that, and make sure that you're also getting 120 so we're not tripped up with the calculator. All right, and remember, this is average damage over the course of the year based on those probabilities. So how does the expected cost of repairs compare to the cost of the insurance plan? Well, the insurance was 180, right? And the expected damage was 120. So the insurance cost was definitely higher than the expected damage cost. So Hira decides not to buy the insurance plan. Instead, she saves $15 per month to put toward phone repairs in case something happens. Do you think this was a good decision? Well, if we save $15 per month, What that means is 15 times 12, and 15 times 12 is $180, right? So $180, if we look back at this list, what's that going to cover? It'll cover the screen damage, but it will not cover minor damage or major damage. So that's 35% of the time that her savings does not cover her. So you might argue, no, didn't save enough to cover minor or major damage, right? Or you could argue yes, because like we saw up here, the insurance costs more. Insurance costs more than the expected value. The expected damage costs more than the average expected damage. Okay, and then, so there's an argument to be made for both of these, whether it's a good decision or not. So passing on the plan is a good idea because the insurance costs more than the damage. It is not a good idea because that savings isn't enough to cover any minor or major damage to the phone. All right, let's go on to the next example. This example is about car accidents and what happens when the accident occurs. So age is one of the biggest factors that impacts your car insurance. And you are probably well aware of that as a teenage driver, if you are in fact driving, that your insurance costs quite a bit. But there's a reason for that. So let's go into some of that data. So the table below shows the annual number of crashes that happen in each age group per 100,000 drivers. Includes 3 different types of crashes and their average costs. Crashes that cause property damage, crashes that cause injuries, and crashes that cause fatalities. All right, so when we go through this, it gives you the cost of each one. So the property damage is an average cost of $4,700. The injury crash, if you crash into somebody, their medical bill's average cost is $65,000. And a fatal crash, if you kill somebody, the average cost to you, probably in some sort of settlement for wrongful death, is going to cost you, on average, $1.75 million. Whoa, it's a lot of money. But luckily, that doesn't happen that often. All right, so now we're going to go through each of these scenarios. So for a driver between 16 and 20 years old, what is the probability that they do these things? Okay, property damage crash, 8,000, 14 times. Out of, remember this was out of 100,000. So if you divide that, you're going to get 0.08 approximately. So about 8%. Right? An injury crash, 6242. Nope, that's going to the next age group. Injury crash, 3174. Okay, out of 100,000. And that's going to be 0.032. So about 3.2%. So that percent goes down, which is good. Causing an injury happens less often than damaging property. And the fatalities, it was 32.45 per 100,000. And that comes out to a very small decimal, 0.0003245. So that is 0.03%. Nice low number there, but that's good because we don't want to be killing people, right? Okay, so any type of crash, probability of any type of crash happening. So what we have to do is add up these 3%. We could add the fractions, but I'm just going to go with the percents because it's already calculated there. And it says mutually exclusive, so this is assuming that you didn't hurt somebody and kill somebody or cause property damage and an injury. All right, so if I do 8% plus 3.2% plus 0.03%, get a grand total of 11.23%. So no crashes? Well, no crashes would be all the rest of the times. So if I start at 100% of the times we drive, subtract out the 11.23% of the time that we caused damage, that's going to leave me with 88.77% non-crashes. Okay, that's pretty good. Now to do the expected value here, what I need to do is go back and multiply the probabilities times the value. Okay, so we'll start with property damage. We have 0.08, right? 0.08 times, actually I'm going to go back, I want to expand this just a little bit because this was a stopping decimal. I feel like I shouldn't be rounding that. 0.081014 was what that probability actually was. And this one was 0.03174. Okay, and that one was correct. So I'm going to go off of these probabilities here when I'm doing this, just to be more exact. All right, so property damage, again, was 0.08014. And when that happens, it's an average cost of $4,700. So we'll multiply the probability of it happening by the cost when it does happen. Okay, and then we'll take, and this is expected value that we're calculating here. If we cause an injury, that's going to happen 0.03174. That's the probability of it happening. The cost when it does happen is $65,000. And causing a fatality is a nice low probability, 0.003245, times the cost, which is quite a bit, $1,750,000. Okay, and then all of this goes into your calculator. Just go straight across, and you can confirm that the total is $3,007.63. So that's the expected value of the damages that this driver causes. All right. That's not good. That's a lot of money. So why would we insure these people? Well, we're going to charge them a lot of money. That's why we would insure these people. Let's go to the next page. Let's look at the expected cost of crashes for a driver between 45 and 64 years old. So this is more my age bracket. All right. So using the same chart, I'm just going to quick update this. So I'm in the 45 to 64 row here. This is what I'm working off of. Okay, and so what I need to do is divide these numbers by 100,000. And so when I do that, I get 0.02977. I get 0.0162. And I get 0.0001888. All of those decimals are found by dividing the number of times it happens by 100,000 drivers. Okay, so to calculate my expected cost for these people, again, probability times value. So it's 0.02977 times that $4,700 property damage plus 0.0162 probability of causing an injury times the cost of an injury, and then the low probability of causing a fatality, 0.0001888, times the cost of a fatality. Okay, throw all that into your calculator. Let's get the expected cost of a 45 to 64-year-old driver. And hopefully you can confirm it's $1,532.32. Okay, which is a lot lower expected cost than a teenager, which might have something to do with why teenagers are so much more expensive to insure. Who is more likely to pay a high car insurance premium, you or your parents? Well, your parents may not quite fall into this age range, but they're probably pretty close. So your parents are going to be costing the insurance company a whole lot less on average than you do on average. And this is not every person, of course, but on average, this is what the only thing that insurance companies can work off of is the numbers. The student is much more likely to cause accidents right? And so, on average, they cost the insurance company more money. And the way it works is the riskier you are in terms of what you're going to cost the insurance company, the more you have to pay to get your policy. So let's go to the next question, this hypothetical. If a law were passed saying that car insurance companies were not allowed to charge different premiums based on age, who do you think would end up paying more? Who do you think would end up paying less? Well, if they pass this law, whose is going to go up? Now, here's the thing. The insurance company has to make the same amount of total money to be able to pay out all the claims. So the older people, they're going to go up. The younger people, they're going to go down, right? Because we still have to get to the same total. So would this pass? Well, who's making the laws? Not the younger people, right? So probably that's not going to happen. Imagine an insurance company is insuring 5,000 drivers between 16 and 20, and they're going to pay 100% of any car accident costs. What is the minimum monthly premium they could charge each driver and expect to break even? Okay, so remember what the cost was per driver, right? So you have $3,007.63 per driver on average per year. So if you break that down to monthly by dividing by 12, we are coming up with a total of a cost of $250.64 per driver per month in this age bracket. Okay, now they're insuring 5,000 drivers. So we're going to keep that in mind as we go through this. If they charge each of them a $275 monthly premium, what would their profits be? Well, profit is determined by taking the revenue brought in minus the expenses laid out. For a car insurance company, the revenue is the amount of money that you pay for your policy, that's just called the premium, and their expenses are the amount that gets paid out. So for every driver, the income is $275 and the expense is $250.64 on average, right? So multiply that by 5,000 and we get our total. Actually, that's going to be monthly, isn't it? Yeah, because these are both monthly amounts. So when you do this calculation, you then have to multiply by 12 to get to a profit or loss for the year. Okay? And when you do that, put that in your calculator. Let's see what we come up with. Looks like we have 1,461,850. Okay, that's a profit because it's a positive number. That's what the insurance company is bringing in just by charging $25 above what they're expecting to pay out. Okay, now they might even charge more than that. They might have way more than 5,000 drivers. So you can see how quickly this $1 million profit goes up and up and up and up. Is the insurance company guaranteed to make exactly that much money? Well, consider what we just did there. We calculated an average, didn't we? So is it possible that of those 5,000 drivers, the probabilities of causing accidents in a given year is actually higher? Sure, there might be way more accidents in a given year in which they're paying out more, and they're not even getting to that $275 average, premium on average. So it's possible that they actually lose money. Well, let's write this out. So the average yearly profit has just been calculated, right? So the average yearly profit is not necessarily what will happen in real life. They do their very best to predict, and they have a lot of statisticians working on their behalf to try to figure out how close this is to what will actually happen in real life. And they need to get as close as they can, but it doesn't always work exactly as they predict. There are many variables involved. right? So who is in the insurance pool? That's one variable. How many have been insured? The more the better for the insurance company. So those variables will contribute to whether it's actually a profit or a loss. Okay, so expected value is a good way to predict things. It's a way to make the decisions that are necessary both on a personal level and on a business level in order to get as close to what actually happens as possible. All right, that's good for this part.